Okay, do you remember what kind of function is it that's written like this? Again, another thing that we did way back in the first chapter or two. Right, it's got two definitions depending on the domain. Piecewise. Piecewise function. So this function equals 2 when x does not equal 3, meaning for every value of x except for 3, the value of the function is 2. When x equals 3, the value of the function is 0, which is a very odd way to construct a function. It's only being done to make this example about limits. Right? So if I graph that, okay, the first line says f of x equals 2 for x not equal to 3. So for every value of x, there's the graph, except for when x equals 3, there's a little hole in the graph, jumps right over the top of it, and the value of the function is 0. So that's the graph we're looking at. Okay. Now let's look at the function from the left, right? As I'm going along from the left, as x approaches 3, the value of the function is 2, 2, 2, 2, 2, 2, 2, 2, 2. I mean, as it gets infinitely close to x equals 3, the value of the function instead is 2, right? So the limit as x approaches 3 from the left equals 2. Same thing from the right, right? As I approach from the right, the value of the function is 2, 2, 2, 2, 2, 2. As it gets infinitely close to x equals 3, it's still 2, so the limit is 2. And since the two limits are the same, the limit is 2. It does not matter that actually the value of the function is 0 at x equals 3. That doesn't matter. The limit is still 2, because that's what it looks like it should be when you get there. You're never going to get there. You just have to estimate based on the trend that if I was allowed to keep going, I think I'm going to get to y equals 2 when I'm at x equals 3. But you don't get there, you don't know that actually you're going to fall into a pit and drop down there. So that's, you know, that's all about just trying to explain limits. I know, like I said, it could be conceptually a little hard to wrap your brain around, but